Hello students. So you should have now watched Tom's video explaining exponential growth, and I'm just going to take you through a little bit more step-by-step process of how he got the numbers. First of all, the assumption here is that we have this basic reproductive number of approximately 3. Remember, that means that every person is approximately going to infect 3 other people, okay? And then the other assumption in this model, and this is why he's going by 5 days, is that the virus is contagious for about 5 days, okay? So here we go. So what happens is on day 1, on day 0, it's just the first person, okay? Now, what happens? In the next 5 days, this person infects 3 other people, and we now have a total, maybe I'll be systematic and put it here. We have it on 4, okay? Now, because we have the assumption that we're contagious for only about 5 days, and this is where I thought that maybe he could have lost some of you. So this person is contagious for the next 5 days, okay? So by the day 10, we still have the 3 people that got the disease 5 days ago, and each of them also infected 3 people, okay? And so what we have now is 12, okay? So what happens then on day 15 is that this person, so this person wasn't infected anymore on day 10, and then this person is now, these people are no longer going to be infected by day 15, okay? But these guys still are, and each of them is going to infect 3 people. So then you got 9 times 3, and so this is why you've got 36 total, okay? And of course you can see the pattern here, and yes, you can just say, oh, duh, it's just multiplying by 3. But first of all, it's not at the beginning, okay? And it's because of this initial person and their case, okay? So I just want you to kind of be able to go through the full process of thinking it through. Trust me, it's worth it. Okay, so then what are we going to do? We're going to drop these 9 people. They got over it or they passed away. Those are the 2 choices, but these 27 are still carrying the virus. And then they also infected 3 more. Okay, so now I'm just going to write this in a little bit more detail. So we have 27 plus the 81. And what we have now is we have 108 cases. And again, yes, you could just multiply this by 3. But I want you to understand why it's working like this, okay? So let's move on. What happens then? Okay, so these 27 are not going to be contagious, right? So we're going to drop these guys, but these 81 are still walking around, da-da-da-da-da. They're going to school, they're going on the subway, they're going shopping. And so as they're doing that on day 21, 22, 23, 24, they are again infecting each about 3 people, okay? So now you've got 81 plus 243, and what does that give us? That gives us 324, okay? And so now you've got 324 total in 25 days just from this one person. All right, last bit. What happens then? Well, in the next 5 days, this guy is not a threat anymore, so we're just going to lose him. And then the 243 are still walking around, still infecting, and still going to infect 3 each. And so what we're going to end up with is 243 729, which will give us 972, okay? And in the video, this is where he's got a little mistake there. At the end there, he grabbed, I think he didn't grab the 243. I believe he grabs the 324 by accident, okay? So what does this mean? This means that you started with 1, and at the end of the month, this one person has 972 active cases. Now notice that this is not even the sum, right? We're not adding all of these up. This is just how many sick people we have on day 30. Okay, so I hope that clears it up for you, and we found a little mistake in the video as well. So you can now go ahead and see what happens when the initial infection rate, so this basic reproductive number, is 1.5 instead, and it really shows just how astounding exponential growth is. Bye.